Solve the following simultaneous equations using the substitution method. State your solution as an ordered pair. The first thing we do is we always label our equations number 1 and number 2. We're going to substitute one of the equations into the other. This is the easiest one to substitute in because it's y equals something. So we can take all of this and substitute it straight in where the y is in our equation. So we're going to sub equation number 2 into equation number 1. And that looks like 4. Instead of y, we write 3x minus 7. Take away 3x equals 8. So we've substituted this value of y where the y was. Now we need to solve for x, so we expand our brackets. 4 times 3x is 12x. Minus 4 times 7 is 28. Take 3x stays, equals to 8. We collect up our like terms on the left. 12x take 3x gives us 9x. Minus, let's move that over a little bit. 9x minus 28 equals 8. We just collected up our like terms. Now we add 28 to both sides of the equal sign. On the left, the 28s will cancel, and we have 9x equals 36. To find out what x is, we need to divide both sides by 9, and we're left with x equals 4. So we know what x is. Now we need to find y. So we need to substitute this x value back into one of the equations. You can substitute into either, but this second equation will give us a little bit less rearranging. So we're going to sub x equals 4 into equation number 2. Just a little bit easier, but we'll get the same solution either way. So y equals 3 times x, which we know is 4, minus 7. Y is equal to 3 times 4 is 12, minus 7 equals 5. So our solution, therefore, the solution is x value first, 4, 5. This is our solution as an ordered pair. Let's have a look at the second pair of simultaneous equations. First thing we do is we always label our equations 1 and 2. Now we can see that both of these equations are y equals something. So we're going to take this part here and substitute it in where the y is, just like we did before. We substitute it in where the y is in that second equation. So we're going to end up with x values on both sides of the equal sign, but that's fine. So we're substituting number 1 into equation number 2. So if we put 2x plus 1 in here where the y is, we have 2x plus 1 equals 5x minus 8. And we need to collect all of our x terms to the same side of the equal sign. This side has more x terms, so we'll collect them over there. To get rid of the 2x, we minus 2x. If we do it to one side of the equation, we have to do it to the other to keep it balanced. So on the left-hand side, we have 1. On the right-hand side, we have 5x, take 2x is 3x, minus 8. We want to isolate the x, so we add 8 to both sides. Get rid of that constant term. On the left, we have 9 equals 3x. 9, and on the right, it's 3x because the 8's cancel. So to find out what x is, we need to divide both sides by 3. And we're left with x is equal to 3. So we found out what x was. We also need to know y. So we substitute our value for x equal to 3 into one of the equations. In this case, it doesn't matter which equation we substitute into. They're both y equals and then an expression. So let's do number 1, but you'll get exactly the same solution if you use number 2. Y equals 2 times x, which in our case is 3, plus 1. Y equals 2 times 3 is 6 plus 1, or y is equal to 7. Therefore, solution is, in an ordered pair, our x coordinate first, 3, and our y coordinate was 7. Now you can go back and you can check that both of these are the solution by substituting back into both of the equations and checking that these solutions make the equations true.